Okay, in this video, we're going to be doing Calc AB problem set number 132. The problems and a playlist are in the description below. Let's see what we're doing. All right, we want to evaluate the integral from 0 to 2 of f of x dx, where f of x is this piecewise function. So it's a quantity x minus 2 squared when x is less than 1. It's 5 when x is equal to 1. And it's 4, the quantity x plus 3 squared when x is greater than 1. So what we got going on here is we actually just have a jump discontinuity at x equals 1. You can integrate straight across a jump discontinuity. You just have to break it up into separate integrals. So what we'll do is we'll go from 0 to 1, and then we'll go from 1 to 2. So let's do that. We're going from 0 to 1. When you are less than 1, you use the quantity x minus 2 squared dx, plus we're going to go from 1 to 2. From 1 to 2, you use 4, the quantity x plus 3 squared dx. And now it's just an annoying problem where we have to integrate this. So for the first integral, we're going to reverse the power rule. We're really reversing the chain rule, but like it just gave you a 1. And we're going from 0 to 1. For the second one, it's the same basic problem. 4/3 quantity x plus 3 cubed, going from 1 to 2. And now we have to fundamental theorem both of these. So when we plug in 1, we get the quantity -1, and then, okay, hold on. I got myself all confused there. When I plug in 1, I get 1 minus 2 is -1 cubed. That's it. When I plug in 0, I get 0 minus 2 is -2 cubed. So I get -1 cubed minus -2 cubed. I don't know why that was hard for me. All right, we get 4/3. When you plug in 2, you get 5 cubed. When you plug in 1, you get 4 cubed, and we're subtracting those. That one was way easier. I think it was the negatives that threw me off. All right, so this will be 1/3. You get -1, and then plus 8. And then here, you're going to get 4/3, 125 minus 64. So that's 4 times 125 minus 64. So we get 7/3 plus 244 over 3. And then overall, that is 251 over 3. That's the value of our definite integral. So you can integrate over a jump discontinuity. Keep that in mind. If you're in Calc AB, you may have to do that for sure. All right, question number 2. Evaluate the integral of 1 over x squared plus 8x plus 160 dx. If you see just a quadratic in the denominator, you should think this is probably arctan. So what we probably want to do is complete the square. So let's see if that works for us. So we got x squared plus 8x. All right, I'm going to leave a giant space, put our 160. Take the coefficient of x, divide it by 2. That gives you 4. Square it, that's 16. We're going to add that and subtract it. So we have 16 minus 16. Now the first 3 things are your perfect square. So that's going to be 1 over the quantity x plus 4 squared. And then just combine what's left to get plus 144. I'm going to take out 144 from everything in the denominator, so 1 over 144. And I'm going to rewrite it so it looks like I like arctan to look. So taking 144 out of 144 gives you the 1. You'll get x plus 4 squared over 144. I'm going to write that as the whole quantity x plus 4 over 12 squared. So it looks kind of like 1 over 1 plus u squared. Let's actually do the u substitution here. So we'll say u is equal to x plus 4 over 12. Which means 12u is x plus 4, or 12 du is equal to dx. This is an indefinite integral, so we can just substitute in. So we got 1 over 144. From dx, you will pick up another 12. And then it'll be the integral of 1 over 1 plus u squared du, which is going to be 1/12 arctan of u, and then plus c. And then u is equal to x plus 4 over 12. So we get 1/12 arctan of x plus 4 over 12 plus c. Whew. So look out for arctans. They come up. All right, the next one. If g of x is the integral from 2 to x squared of cosecant squared of 2t minus 5t squared, find g double prime. All right, so we're going to find g prime using the second fundamental theorem. So it's you take the upper bound and you substitute it in. So every t becomes an x squared. So it'll be the quantity cosecant squared of 2x squared minus 5x squared squared, which is x to the 4th, times the derivative of the upper bound. The derivative of the upper bound is 2x. Okay, I'm actually going to rewrite this because we need to find the second derivative, and I think it'd be better if we had expanded this. So 2x cosecant squared of 2x squared minus 10x to the fifth. All right, here goes. For the first part, we need to use the product rule. So it's going to be first, which is 2x, derivative of the second. So that's going to be 2 cosecant of 2x squared times the derivative of cosecant of 2x squared, which is negative cosecant of 2x squared cotan of 2x squared times the derivative of 2x squared, which is 4x. That's first derivative of the second. Plus now we need to do second derivative of the first, which is much easier. It's cosecant squared of 2x squared times the derivative of 2x, which is just 2. And also we need the derivative of our negative 10x to the fifth. So that's minus 50x to the fourth. I'm not going to make you watch this, but I decided to simplify this. And so I ended up with this. G double prime is negative 16x squared cosecant squared of 2x squared cotan of 2x squared plus 2 cosecant squared of 2x squared minus 50x to the fourth. Kind of gross, but not a bad problem. All right, I hope this is the end of the problem set, so I hope you found this helpful, and good luck.